welcome to our show today. This is it's a real treat. It's a strange treat, I must admit. Ordinarily, for what we're doing now, Hayden and I would be together in a field. It's all really part of a bigger project between Bournemouth University and Hengistbury Head, where we have a HLF funded project where we're doing experimental archaeology as part of public outreach, but also as part of research. So Hayden's doing a PhD looking at the metallurgy of Hengistbury Head and using experimental archaeology to help understand the material found at Hengistbury and some of the things that would have happened on the head, and alongside that share some experiences of it with the public as we are today. So the aim really of the project is to use experiment to understand archaeology while also sharing the magic and the actual fleshed out human side of archaeology, rather than thinking of metallurgy as a crusty old bit of slag in a ditch at Hengistbury Head or a small clay hearth in a field. It's an embodied process. It's a process that human beings would have done. Human beings not unlike Hayden, possibly in bigger groups than he is today. So that's why we're doing it, really. It's about engaging with the technology of the past, experiencing things that may have been experienced, but also giving us analogues for what we see in the archaeological record. And you can probably see around Hayden there's various patches of ash, there's bits of burnt material, there's a skull, a symbolic offering, some ceramic vessels, lots of different bits of archaeological remains that we'd see in the archaeological record, and we can use experiment to help understand what role they may have played in the process and how people would have engaged with those spaces and areas. The first thing that Hayden would have done in this process is build the hearth itself. In this case, we're using a bowl hearth, which is an archaeological feature that we see on sites. It's a small clay-lined pit. We tend to only find the truncated element of it, so the bottom bit, often it gets lost in ploughing. So we have to infer what type of superstructure it has. In this case, we're going very minimal. We're using a fairly lo-fi example. We're basing it on almost the minimum building we can get away with the archaeological evidence that we have. And that's something Hayden and I have been researching collectively now for probably 3 years, Hayden, 4 years. When did you finish your undergrad?
Don't tell me. Yeah, about 4 years, could be 5 soon.
One of the really unique characteristics, particularly of early metallurgy in Britain, is it's near invisible in some places. We know from proxy evidence that it happens, but in areas like the Great Orme in Wales, where we know there's mining, we know there's exploitation of minerals, the actual features for smelting are incredibly ephemeral and very hard to find. So Hayden and I have been exploring ways of doing metallurgy, leaving as minimal a recognizable impact as possible. Now, the furnace we'd expect in this instance to get up to around 1300 degrees or thereabouts, which for many materials, in terms of the bellows themselves, would melt or burn at that temperature. So we make a small clay tube that is basically the interface between the two, and the bellows are resting in that. The reason we use bellows and the reasons we use charcoal is because A, it allows us to get a nice high temperature, but it also allows us to get an atmosphere that facilitates a good cast in this instance, hot enough to temperature. Now, what you won't have seen, because we had to do this early on, is Hayden charged a crucible. So a crucible is a ceramic vessel that we use to melt the metal. Here's one we made earlier. Blue Peter badge is on its way. Based on a prehistoric example, a fairly open vessel. And what we do is blast hot air into that vessel from above. You'll see it's a fairly open vessel. And the reason we do that is when you blast hot air at a ceramic, they're functioning right on the edge of their tolerances, their ability to survive. And actually, you can melt crucibles quite comfortably in a furnace like that. So within the furnace, we've got the crucible, an open crucible, as I was saying.
A mixture of copper and tin as well.
Copper and tin, that's right. So we're doing the alloying as we go today, aren't we, Hayden?
Yeah, it's a bit tricky. We ran out of bronze, and I was like, oh God, got to get set up. Oh my God. and we haven't got any bronze ready. So actually, we're trying to alloy the two metals together to make bronze, which is copper and then a little bit of tin. The reason why that's a bit more of a problem is ideally we've got to get the copper to melt around about 1,150 degrees. That's really hot. And the ceramic which holds it, the crucible, starts to dissolve around about 1,000 degrees. So we have to very rapidly, but in a controlled manner, heat it up, melt the copper, which then mixes with the tin. And the tin melts at a much lower temperature.
The thing it's very hard to see, but what's happening in that furnace is an incredibly volatile reaction at the moment. The lining of the crucible's made of clay, so it's an aluminium silicate. The metal in there, the copper, the tin, it's all reacting with each other. So the surface of the crucible will be melting with the flux of the ash, the alkali of the ash from the charcoal will be facilitating a glass even forming on that crucible, and that will be reacting with the metal that's melting, and it's a very, very unpredictable process. And even in modern foundries, there's a 1 in 3 failure rate with castings, which is incredibly high. And I also say now as a disclaimer for Hayden ahead of the eventual cast, I'm sure it'll be fine.
Yeah.
So you can, on a good day, you can get a furnace like this up to temperature in about 20 minutes to half an hour, chuck in a crucible, melt for maybe 15 to 20 minutes if you're feeling particularly strong and bellowy. You'll see at the moment Hayden's fueling up as he goes. So at the moment, the furnace is losing an incredible amount of heat. No pressure, Hayden.
I know, yeah.
But when you've got multiple people, you can carry on bellowing as you fuel up, and you can actually get the temperatures in really efficiently and really rapidly. It'll be a little bit longer today because we want to make sure that when Hayden reaches in to get that crucible out, that it's properly melted. It's going to hold its melt for long enough to get that cast. What we'll be anticipating at that stage, you can see down the bottom there a piece of wood with some clay in it, and that is our mold. And Hayden's been experimenting the last few weeks looking again at how we can do metallurgy leaving very little trace. And something we've realized, I say we again, the royal way, something Hayden's realized is you can carve something into wood and line it with a very, very thin layer of clay, and it works as a pretty decent crucible. What we would normally do is one of us would pick up the crucible with tongs, nice two-handed and secure. The other one would scrape away the excess charcoal and then pour into the mold, And that, I think that highlights a little bit of something about these kind of processes. They're not something one person tends to do alone of a Saturday afternoon. They're quite a communal process where lots of people would have to dedicate serious time to doing this. And when we think about the extent of metal, the volume of metal we see in the archaeological record, this is a full-time specialism for groups of people beyond 1 or 2 individuals, from mining an ore to processing that ore to smelting the metal itself to making the metal and then to forming that metal into a finished object. It's a huge process. It requires specialisms on the metallurgical front, but also looking at what you can see in front of you, carpenters, woodworkers, leather workers, tanners, clay processing, clay production, potting, charcoal making is a huge community endeavor. And that's one of the reasons when we talk about metallurgy and archaeology, it tends to be seen alongside increasing complexity, societies becoming more hierarchical, becoming more structured in that sense, to allow full-time specialists. So the things Hayden will be looking out for now is stuff like the color of the flame, the feel of the temperature. Actually, when you're at this stage of a cast, it's hard to describe the type of heat that you feel coming off of a furnace. It's somewhere between opening a log burner and burning your eyebrows off. It's a very unique feeling, and as you take a furnace up to temperature, you feel it get hotter and hotter and hotter. The color will get whiter and whiter to the point where Hayden's looking in at the crucible there, it will start to really hurt your eyes to look for too long.
Right. Oh yeah, brilliant. Oh God.
Have an applause of one for that, Hayden. That is one of the best casts I've ever seen you do.
That nerve-wracking, absolutely nerve-wracking. Brilliant. All right then, let's see what we've made. And actually, you know, even the clay lining of the mold isn't even that badly damaged, you know. Oh yeah.
Look at that. Oh, you can see the oxidization live and in HD there. That was wonderful.
Beautiful. Now it's quite a chunky, you know, you can try a chunky spear, but we'd render that down probably by a little bit of cold working around the edges to harden it, but then mainly by files. But there you go. Alloyed bronze cast.
But thank you so much for joining us. It's been a real pleasure chatting to you and sharing this with you all. So thank you very much.
Yeah, absolutely.
And we'll stick the video on YouTube in case you want to show it to your friends later.
Brilliant. Right then. Okay. Thank you very much.
Okay. Bye-bye.